Hello, and thanks for joining me at IT Home Lab Online. In this video, we're going to install Virtual DSM, that's Synology's disk manager, as a Docker container on an Ubuntu virtual machine running on Proxmox. By the end of the video, you'll have a full working DSM instance running in your home lab, accessible from your browser locally and remotely via Tailscale, with all of your data stored in your standard persistent config layout. Before we get into it though, just a quick but important disclaimer. The Virtual DSM project on Docker Hub contains only open source code and doesn't distribute any copyrighted material, so the project itself is legal. However, Synology's end-user license agreement only permits DSM to be installed on official Synology hardware. Running it anywhere else, including inside a virtual machine, is a violation of the end-user license agreement. I'm covering this for educational and home lab purposes only. If you decide to follow along, that's your call to make. I'd encourage you to read Synology's EULA before you do. The main purpose for setting this up is so that you can give yourself an example of what the interface looks like before you commit to spending big money on a Synology NAS. So for this exercise, I'm going to use my Dell Latitude 5411 running Proxmox with an Ubuntu 2604 virtual machine as the Docker host. I've got a video in the link below to show you how to set all of that up. Now, let's get started. The first thing we need to do is confirm that nested virtualization is enabled on your Ubuntu VM. Virtual DSM runs a full Synology operating system internally using QEMU and KVM, and KVM inside a VM requires the host to pass through its virtualization extensions. Without it, the container won't find a KVM device and will either fail to start up or fall back to pure software emulation, which is painfully slow. To enable nested virtualization, shut down the virtual machine fully in Proxmox, not just reboot. It needs to be turned off. Then go into the virtual machine's hardware settings, select CPU and change the CPU type to host. That tells Proxmox to expose the physical CPU's full features to the VM, including the virtualization extensions that KVM needs. I'll go into the Proxmox interface now and show you what we're talking about. So this is the setting here. Go into your hardware, go into your processors, click edit, and you can see here the type is set to host. I've already done mine. If yours isn't set to host, just go into this drop down, scroll down to the very bottom and select host from there. Okay, once you've done that, we'll do a SSH into our Docker. Okay, now there's a command that we can run called kvm OK, and they'll confirm that it's been set up correctly. If it's not installed, then you can simply install it, and it's part of the CPU checker tools. Okay, so you can see here that it does exist and acceleration can be used. Okay, so once we've done that, we'll skip through to my pre-made Docker container. So I've created a folder here called NAS under my scripts folder. This means that when I compose my my YAML script, it'll create its own section in here for NAS in the stack. So I'll quickly step through what I've got within my container. So this is the compose file that I've created. So if you have a look at this configuration here, I've just modified this slightly from the original website. I've set my disk size to 64 gig. You can set the amount of RAM and number of CPUs. Number of CPUs by default is 2 and 2 gig of RAM. I've left that as it is, just for this demonstration purposes. Now I've also added in this little section here, this additional volume file. I had issues getting mine to pull down this DSM image directly from Synology. So I've done a little bit of a workaround and manually download that. So if you don't have this line here, what it will do is it will attempt to automatically pull down the image file from Synology. As I said, I had trouble with that. So I'm manually mapping it and I'm manually downloading it. And then if you just have a look a little bit further down here, you can see my Tailscale sidecar. It uses the TS auth key, which is found in the environment variable. And up here, you can see my configuration environment variable as well. So that just sets the paths that I use as a standard. So I'll quickly show you the environment variable now. So you can see here, I've got my time zone, my configuration path there, my user ID, credentials, or authorization, and my Tailscale key. Now I also use a second environment file so that I can demonstrate to you the auth key without putting in my actual auth key. But what you would do is you would generate the auth key through Tailscale, go into your settings, go into keys, and generate an auth key here. I've set mine up as a reusable multiple use key with an expiration of 90 days. You can create a one-off key for this purpose if you choose to. So once I've done that, I'll go back to my machines so you can see this is the existing machines. Once I've run up my containers, it will create a new entry in here for my DSM. Now, what I've also done to make it a bit easier is I've created a build script, which you're free to download and use from the GitHub. So this is the steps that it goes through. So it makes sure that there's that if I already had DSM running, it would shut it down, makes a directory to store the configuration files. This takes ownership of that directory and assigns it to my user and my user group for this particular folder. This is the command here that downloads the virtual DSM, the virtual DSM image from Synology. Then once I've downloaded that, I take ownership again to make sure that the container has full access to this boot file. Here is where I set my environment variables. I've done it a couple of different ways just to demonstrate that it could be done two different ways. So basically what this is saying is set the source to use this environment file, which is in my scripts folder, and this is my secrets folder, and that's where it finalizes that environment set. Here's my Docker Compose command, which again loads up the environment file. So if you didn't have this section here, you could just run this section. And that just tells it basically to use the variables from both of those files. Ignore this is just a comment. I do have this as an alias as well, this whole command, because I can reuse it over and over again. Once it's completed compiling it, I've got just a delay of 15 seconds here, and then I tell it to serve up Tailscale using the IP address within the compose file. and port 5000. It'll serve that up as HTTPS on Tailscale. So now I'm just going to run the build script. So you can see, you can ignore these errors because when I did my Docker compose down, I wasn't referencing the variables correctly. But for shutting it down, that's fine. The important thing is when I'm bringing it back up again, that it's using the correct environment variables here. So it's downloading that Virtual DSM folder there. Okay, this is the 15-second delay at the end that I was referring to. Okay, so now it's done the serve of HTTPS. So if I go back into Tailscale now, you can see my number of machines has increased to 9. I go down the bottom here, there's a new virtual machine, DSM. So now if I go to HTTPS, DSM, and my Tailscale domain, enter, it'll take a moment because it's setting up a new certificate for that particular domain that hasn't existed before. And I can view that by going in here, having a look at the logs, and you can see it's going through the Acme challenge, setting up the Let's Encrypt certificate. Come back here now and see it's finished the certificate, so it's actually brought up the interface. And now I can go in here and I can start to configure the device. So firstly, I'll give it a name. I'll just call it DSM. You can call it whatever you like, Synology. I'll set up an administrator account. Try not to use a generic admin name. It just means that it's one extra step that hackers will have to use to try and get in. So I'll call this one Demo Lab and set a strong password here. So I'm going to use something really, really, really strong, Demo Lab 123, because I'm just demonstrating. We won't register it with Synology or anything like that. Okay, it has to be a stronger password. So, okay. So Demo Lab 123, exclamation mark, exclamation mark, exclamation mark, demo. Make sure they're matching. Okay. Let's make it Emo Lab. Doesn't like to include the username in the... I'm going to save that for now, just for my convenience. Obviously, if you're in the real world, you wouldn't be saving this into your browser. You'd be using a password manager of some sort. Now, I'm going to turn off the automatic updates because I'm not sure whether they're going to break it. And as I said, this is just to give me a feel of what the DSM software feels like before I commit to purchasing my Synology NAS. Okay, so we'll skip by the look of it. I don't want to collect any data. Okay, so automatically it's giving you these options to install some of their software, but I'll have a look at that later. And I'm not going to enable two-factor authentication. And I don't want to secure my account. Okay. So there we have it. You've got Virtual DSM installed. Go into File Station, you won't see any folders yet. Need to create a volume. So we'll start with just calling it shared. I don't want to have it as a recycle bin on it. Don't need any extra security. You can go through and configure this however you choose. Basically, so my default account has access to the share. So now when I come back here, I've got this folder shared, and I can create folders, upload, I can map this share, and do everything that you can do on a Synology NAS. So that's it. Virtual DSM for your evaluation purposes. So if you found this video helpful, please like and subscribe and hit the notification bell. Thanks for watching, and I'll see you in the next one.